In this lecture, we will introduce 6 drivers of logistics system. These drivers interact each other, and the structure of this driver determine how the supply chain or logistics system work or operate. It also determines the logistics system's performance. I will follow the outline to introduce this lecture. I will first introduce 6 drivers of logistics system and then talk about their cost relationship for these drivers. Learning objective in this lecture. After this lecture, you should be able to identify the major drivers of logistics system. Describe the role of each drivers in logistics strategy and competitive strategy. And you should be able to discuss the cost relationship for the drivers. The 6 drivers to shape a logistics system are facility, transportation, inventory, information, sourcing, and pricing. And 3 logistics drivers are facility, transportation, and inventory. These 3 drivers determine how the material flow, product flow, and the related service flow work in the logistics system. And the other 3 driver, information, sourcing, and pricing, are called cross-functional driver. This driver can be used in design, planning, and operation of the supply chain. And the 6 drivers interact with each other to determine the supply chain's performance in terms of responsiveness and efficiency. And the structure of this driver also determine how the logistics system work and operate. So it's very important to know these 6 drivers because it usually used to design your logistics system, and it also the structure of this 6 driver also determine the performance of your logistics system. We first start to introduce the 3 logistical drivers. The 3 logistical drivers are facilities, transportation, and inventory. We can think of inventory as what is being passed along the supply chain, and transportation as how it is passed along the supply chain. Facility are the where of the supply chain. The facilities are the locations to or from which the inventory is transported. Within a facility, inventory is either transformed into another state, or say manufacturing, or it is stored, say warehousing. Facilities are the actual physical locations in the supply chain network where product is stored, assembled, or fabricated. The two major types of facilities are production sites and storage sites. Decisions regarding the raw location, capacity, and flexibility of facilities have a significant impact on the supply chain's performance. For example, an auto parts distributor striving for responsiveness could have many warehousing facilities located close to customers, even though this practice reduces efficiency. Alternatively, a high efficiency distributor would have fewer warehouses to increase efficiency despite the fact that this practice will reduce responsiveness. Facilities are a key driver of supply chain performance in terms of responsiveness and efficiency. Companies can gain economics of scale when a product is manufactured or stored in only one location. This centralization increases efficiency. The cost reduction, however, comes at the expense of responsiveness, as many of a company's customers may be located far from the production facility. The opposite is also true. Locating facilities close to customers increases the number of facilities needed and consequently reduces efficiency. If the customer demands and is willing to pay for the responsiveness that having numerous facilities adds. However, this facility decision helps meet companies' competitive strategy goal. Decisions regarding facilities are a crucial part of supply chain design. There are three important decisions related to facilities. The first one is location. Deciding where a company will locate its facilities constitute a large part of the design of supply chain. A basic trade-off is whether to centralize in order to gain economics of scale or to decentralize to become more responsive by being closer to the customer. Companies must consider a host of issues related to the various characters of the location area in which the facility is situated, include macroeconomic factors, quality of worker, cost of workers, cost of facility, availability of infrastructure, proximity to customer, the location of that firm's other facilities, tax effects, and other strategic factors. The second decision is capacity. Companies must determine a facility's capacity to perform its intended function. A large amount of excess capacity allows the facility to be very flexible and to respond to wide swings in the demands. Excess capacity, however, costs money and therefore can decrease efficiency. A facility with little excess capacity will likely be more efficient per unit of product. it produces than one with a lot of unused capacity. The high utilization facility will have difficulty responding to demand fluctuations. Therefore, a company must make a trade-off to determine the right amount of capacity to have at each of its facilities. Another important decision is the role of these facilities, whether used as manufacturing or warehousing in this facility, and what kind of method to be used for manufacture or warehouse. Or, for example, the manufacturing could be flexible or dedicated, or a combination of the two. Whether we use a product-focused facility to produce our product, or we use a functional-focused method to produce the product. For warehouse, we have to decide whether we use cross-docking or storage facilities, and this kind of decision have to be determined when we set up a facility. The second driver we want to talk about is transportation. Transportation moves product between different stages in a supply chain. Like the other supply chain drivers, transportation has a large impact on both responsiveness and efficiency. Fast transportation allows a supply chain to be more responsive but reduce its efficiency. The type of transportation a company uses also affects the inventory and facility locations in the supply chain. For example, Dell flies some components from Asia because doing so allows the company to lower the level of inventory it holds. Such a practice also increases responsiveness but decreases transportation efficiency because it is more costly than transporting parts by ship. The role of transportation in a company's competitive strategy figures in the company's consideration of the target customer's needs. If a firm's competitive strategy targets a customer who demands a very high level of responsiveness, and that customer is willing to pay for this responsiveness, then a firm can use transportation as one driver for making the supply chain more responsive. The opposite holds true as well. If a company's competitive strategy targets customers whose main decision criteria is price, then the company can use transportation to lower the cost of the product at the expense of responsiveness. Because a company may use both inventory and transportation to increase responsiveness or efficiency, the ultimate decision for the company often means finding the right balance between the two. The decisions related to transportation that companies must consider are the mode of transportation, the choice of transportation mode. The mode of transportation is the manner in which a product is moved from one location in the supply chain network to another. Companies can choose between air, truck, rail, sea, and pipeline as modes of transportation for products. Today, information goods can also be sent via the Internet. Each mode has different characteristics with respect to the speed, size of shipments, cost of shipping, and flexibility that lead companies to choose one particular mode over the others. Another decision is route and network selection. Design of transportation network. The transportation network is the collection of transportation modes, locations, and routes along which product can be shipped. A company must decide whether transportation from a supply source will be direct to the demand point or will go through intermediate consolidation points. Design decisions also include whether multiple supply or demand points will be included in a single run or not. Companies must also decide on the set of transportation modes that will be used. Another decision is the company need to consider whether transportation is in-house or outsourced to the third-party logistic company. In-house transportation usually require a big investment in the initial stages and also take time to set up the transportation network and to build up the transportation fleet. So it cost a lot of money in the very beginning to set up the initial network and fleet. However, it will significantly reduce the operation cost after you set up the transportation network. Another choice is to outsource the transportation to the third-party logistic. If this is the choice, the companies do not have to set up the transportation network and build up the transportation fleet. It reduces the money in the initial setup stage, and it can immediately use the third-party logistics transportation network and different mode of transportation. However, for sure, the operation cost will be higher than in-house transportation. So a company have to make decision that which one, whether in-house or outsource, is the best fit for their needs and best fit for their competitive strategy. Inventory exists in the supply chain because of a mismatch between supply and demand. This mismatch is intentionally used in some industry. It is economical to manufacture in large lots that are then stored for future sale or for the future demand. An important role that inventory placed in the supply chain is to increase the amount of demand that can be satisfied by having the product ready and available when the customer wanted it. Another significant role that inventory plays is to reduce cost by exploiting economies of scale that may exist during production and distribution. Inventory is held throughout the supply chain in the form of raw materials, work in process, and finished goods. Inventory is a major source of cost in the supply chain and has a huge impact on responsiveness. If we think of the responsiveness spectrum, the location and quantity of inventory can improve the supply chain from one end of the spectrum to the other, means the extreme the one of the extreme end of responsiveness to another extreme end of the spectrum of efficiency. For example, an April supply chain with high inventory levels at the retail stage has a high level of responsiveness because a customer can walk into a store and walk out with the shirt he or she was looking for. In contrast, an April supply chain with little inventory could be very efficient but would make customers wait several weeks or even months for their clothes. Inventory plays a significant role in a supply chain's ability to support a firm's competitive strategy. If a firm's competitive strategy requires a very high level of responsiveness, a company can achieve this responsiveness by locating large amounts of inventory close to the customer. Conversely, a company can also use inventory to become more efficient by reducing inventory through centralized stocking. The latter strategy would support a competitive strategy of being a low-cost producer. The trade-off implicit in the inventory driver is between the responsiveness that results from more inventory and the efficiency that results from less inventory. The major inventory-related decisions that supply chain manager must to make are following. The first one is the cycle inventory. Cycle inventory is the average amount of inventory used to satisfy demand between receipts of supplier shipments. The size of the cycle inventory is a result of the production, transportation, or purchase of material in large lots. Companies produce or purchase in large lots to exploit economies of scale in the production, transportation, or purchasing process. With the increase in lot size also comes an increase in carrying costs. The basic trade-off supply chain managers face is the cost of holding larger lots of inventory, when cycle inventory is high versus the cost of ordering product frequently when cycle inventory is low. Another decision is the safety inventory. Safety inventory is inventory held in case demand exceeds expectation. It is held to counter uncertainty. If the world were perfectly predictable, only cycle inventory would be needed. Because demand is uncertain and may exceed expectations, companies hold safety inventory to satisfy an unexpectedly high demand. Managers face a key decision when determining how much safety inventory to hold. Therefore, choosing safety inventory involves making a trade-off between the costs of having too much inventory and the costs of losing sales due to not having enough inventory. Another decision is seasonal inventory. Seasonal inventory is built up to counter predictable variability in demand. Companies using seasonal inventory build up inventory in periods of low demand and store it for periods of high demand when they will not have the capacity to produce all that is demanded. Managers face key decisions in determining whether to build seasonal inventory, and if they do build it, in deciding how much to build. If a company can rapidly change the rate of its production system at a very low cost, then it may not need seasonal inventory, because the production system can adjust to a period of high demand without incurring large costs. However, if changing the rate of production is expensive, then a company would be wise to establish a smooth production rate and build up its inventory during periods of low demand. Therefore, the basic trade-off supply chain managers face in determining how much seasonal inventory to build is the cost of carrying the additional seasonal inventory versus the cost of having a more flexible production rate. The fundamental trade-off that managers face when making inventory decisions is between responsiveness and efficiency. Increasing inventory generally makes the supply chain more responsive to the customer. A higher level of inventory also facilitates a reduction in production and transportation costs because of improved economics of scale in both functions. This choice, however, increases inventory holding cost